Hello and welcome back to the Algebra 2 Summer Packet videos. Today we're going to be doing 17 through 24. I'm Mrs. Engelman and I'm here with Mr. Villarreal. We call him Mr. B. And let's start on problem 17. Problem 17 gives you 4 graphs that are inequalities and 4 equations that are also inequalities and asks you to match the equation to the graph. If you look at the 4 graphs, you will see that 2 of them have solid lines and 2 of them have dashed lines. How do I know which equation goes with which? Well, I can use the fact that 2 of the equations are strict inequalities. This one is y greater than negative 3x plus 5. This is y less than negative 3x plus 5. Over here, notice the difference. I have an equal sign on both of them. Consequently, problems 1 and 2 are going to go with graphs B and D. Dashed lines imply strict inequality. Solid lines imply equality along with the inequality. That means that the points on the line are actually part of the solution, whereas the points on the dashed line are not. Okay, so now we know that problems 1 and 2 are going to go with graphs B and D, and problems 3 and 4 are going to go with graphs A and C. Now how do we determine which goes with which? If you look at the shading, when you shade to the left, you're shading solutions less than, and when you shade to the right, you're shading solutions that are greater than. So that would imply that graph D goes with number 1, and graph B goes with number 2. Similarly, for 3 and 4, graph A is going to go with number 4, and graph C is going to go with number 3. And that's your answer. Mr. B, would you like to take the next one?
Yes. Hi, I'm Mr. B. The next question is graph the lines accurately, plot and label at least 3 points on each graph. As you see, the first one is a linear equation in the form of y is equal to mx plus b, whereas b is the y-intercept and m is the slope. So using this, we can easily plot the graph on the coordinate plane. So the y-intercept in this case is 1, and you go to 0, 1 here. And then the slope is 3, which is 3 over 1, rise 3 and run 1, rise 3, run 1, rise 3 and run 1. Using these 3 points, we can draw a straight line through these points. So that's a graph of y is equal to mx plus b. The next one is not given in the slope-intercept form, so we need to change it to a slope-intercept form. To do this, just move the 3x to the other side. Since these two are not like terms, we don't combine them, and we'll have 2y equals minus 3x plus 6. Then to isolate the y, divide by 2 the whole thing. So this comes y equals minus 3 over 2x plus 3. Now in this case, our slope is minus 3 over 2 and the y-intercept is 3. Go on 3, plot the points, then it tells you go down 3, run 2, down 3 and run 2. Since this is a negative slope, we go from left, right, decreasing. 1, 2, 3, then 2. These are the 3 points, which is enough to draw. Then use your ruler, not like me, like this, and this is roughly the graph of y is equal to minus 3x plus 2 plus 3.
Marvelous. Okay, let's move on to problem 19. Problem 19 is talking about average speed on the interval 2 to 5. When you're looking for an average speed, you're going to come and you're going to take the points 2 and the corresponding distance, and 5 and its corresponding distance, and you're going to run this like slope. So you're going to take 125 minus 20 over 5 minus 2. That's going to give you 105 over 3. When you divide 105 by 3, you get 35. And looking back at your units is feet per second. Marvelous.
The next one is the same question, getting the average rate of the growth of bacteria given the graph. So we're going to follow the same procedure at the question on number 19. The first point is at 1,5 and the last point is at point 6,40. So using these two coordinates, we can find the average rate of growth, that's the slope, which is 40 minus 5 over 6 minus 1. It's going to be 35 over 5, which is equal to 7. So the average rate of growth for bacteria is 7 bacteria per hour.
Great. Okay, moving on to problem 21, solving literal equations. I love these because you just never know when you're given an equation all the different ways that you can solve. If you look at this equation, this asks you to solve for r, but notice you have a, you have p, and you have t. You could solve the equation for any of these things. But right now they want us to solve for r. So what you want to think of is leave the r where it stands and move everybody else. So if a equals p plus prt, you want to move this p to the other side. So a minus p is equal to prt. And notice the reason I subtracted p was because it was being added. Now I want to solve for r, this guy right here. So I'm going to be moving the p and the t, and since they're multiplied right now, I can do them both at the same time by division, which is what I'm going to do. So I'm also going to switch this around in the end. So r is equal to a minus p over pt. Okay. Over here, they want us to solve for z. Solve for z. So, again, I want to leave z alone. Leave alone, okay? Everybody else is going to move. So, first thing I'm going to do is leave my 3z, my multiplication here, and I'm going to move both of these, this and this, to the other side. Notice this guy's positive over here, as is this, so when they come to the other side, they're going to be negative. So this is going to be negative 2x, and this is going to be minus 12. The last thing I have to do is divide away this multiplier, which I'm going to do to all terms. So this is going to be z. Negative over negative is positive. This is going to be 2/3 x, and negative 4 divided by, or negative 12 divided by negative 3 is positive 4. 12 off.
Perfect. All right, this is a transformation question. The following question explores the relation between y is equal to f of x and y is equal to a f of x minus h plus k, and the effect of a, h, and k in transformation of the function f of x. Which of the following graphs represent the function f of x plus 3? Which of the following represent absolute value of x plus 3? Now the question is to know what the effect of this do when given the function. So for example, if you have, this is a, the coefficient of the highest term, and this is k, which is the extension, always this one do stretch or shrink the graph vertically, and this one moves from left to right, and this one moves the graph up, down. So in this case, in our case, this is h, which is positive. Always, if it is positive, it moves to the left. If it is negative here, it moves to the right, the given unit. So in this case, f of x plus 3 means it moves to the left 3 units. So from the original graph, which is f of x as a coordinate of, it should be like this here. This is the original y is equal to absolute value of f of x. F of x is equal to absolute value of x. So this move 3 units to the left. So your choice is simply the A1. This is f of x is equal to absolute value of x plus 3. Because this 3 in a positive means will move left 3 units. And if it was negative here, we're going to pick this answer. But if it's plus, it move left. If it's negative, it move right. Whereas this one is a k. As you see from the general form, k is up and down. If it is positive, it go up. If it is negative, it go down. Obviously, this answer will be B. So the answer for this is A and D.
All right, let's take a look at 23, just 2 more to go. All right. Oh, this is B for 22. There's the second part here.
Okay. Okay. The following question again is the same. As I said, what you have to know here is always this one. The effect is either it will stretch it if it's a big number like more than 1. We don't consider the sign. If it is greater than 1, it will stretch. And if it is less than 1, between 0 and 1, a fraction number, less than 1, this will stretch vertically, and this one shrink vertically. That means the graph goes fast up like this one here. You can see that this is stretching vertically, whereas if you shrink it vertically down, it looks like the graph in the second one. So when it got fatter, we call it shrink vertically. When it's getting thinner on closer to the y-axis fast, it will be stretched vertically. So as you see, we just have to look on the coefficient. The effect of this negative sign is either the parabola opens up or opens down. So in this case, it's negative, it opens down. So we're gonna go opens down but wide, because this number is small number between 0 and 1. So we're gonna go for this one is 3. Whereas the second one, y is equal to 4. 4 is a big number and it's upward parabola. A big number means stretch vertically, which is the first one. And this one is a downward parabola but stretch vertically, which is number 4. And this one is smaller, which is shrink vertically, but it is upward parabola. It goes for number 2. Go ahead, the next one.
Yep. Okay, so now we're looking at where a quadratic intersects a horizontal line. We have the equations y equals x squared minus 4x minus 6, and we have y equals 7. And it's very important that you understand the difference between these two questions. This is strictly equal to, whereas this is less than or equal to. So, take a look at this, equal to. What you want to know is, this is another way of saying, where do these two equations or graphs intersect? So, where do the two graphs intersect? As you can see, they intersect at -2. So x equals -2 is the solution. And they also intersect here, and they intersect at 1, 2, 3, 4, 5, 6. X is +6. Okay, so just 2 answers for this. But that is not the same question as this one. We're looking for all x values that yield a number that is less than or equal to 7. So the way to do that, the best way to do that, is to try some x's on either side of these two. So put these down here, these two numbers that you found. So after you've drawn your number line with the two solutions of equality, take a number to either side of -2, first of all. So let's take -3 from the left, plug it in. When you plug it in, you will see that you get a value that is greater than. So let's just put it in there. This is going to give you 9, this is going to give you 12, and then you're going to subtract 5 from that, so that's going to be, it's greater than 7. So this is greater than. Whereas if you take a number in between, like 0, which is the easiest one to do, and plug 0 in, you get -5 less than or equal to 7, which is true. So that's true. And here, if you take 7, you get 49. When you subtract 28, you still have a pretty big number. When you subtract 5 more, it's going to be clearly larger than 7. So your answers are going to be between -2 and 6. So you write -2 less than or equal to x less than or equal to 6. That's it.
All right. Okay, the last part of the equation is solve the following linear equation. What you have to do is it's a process of isolating the x. Bring the x to one side and the other part to the other side. First, you have to distribute in order to remove the parentheses. So in this case, it's going to be -12 plus 4x when you go like this, and negative times negative is positive. Same process here, 2 times x is 2x minus 12. Now bring the x to one side and the numbers to the other side. To bring this, subtract 2x here, subtract 2x here, add 12 on the other side. So this will cross out, and you will have 2x is equal to this. All of them will go equal to 0. Divide by 2, divide by 2, x is equal to 0 will be the solution. You can check it this by plugging back in the equation if you want to. If you plug back, this is -4 times 3, since you put 0 here. And if you plug 0 here, 2 times -6 is -12. -12 is equal to -12. You are okay to have the answer x equal to 0. Same thing here, distribute this one. First, to remove the parentheses, this is going to be 3x minus 2x minus 2 equal to 0. Combine like terms, have the same variable in the same power, which is 3x minus 2x is x, minus 2 is equal to 0, plus 2 plus 2, x is equal to 2 would be the answer for this one. And the same thing here, first distribute 8x plus 12 plus 8 is equal to 6x. Now bring the variables to one side and the number to the other side. This is going to be 8x plus 20 equal to 6x minus 6x minus 6x here, and move the 20 to the other side. Minus 20 minus 20 is going to be 2x equal to minus 20. Let's cross out and divide by 2 by 2, x equal to -10. The final for me, this is going to be 6x plus 12 plus 1 is equal to 2x plus 8. Now again, collect like terms, I mean the same variables to one side and the numbers to the other side. This is simplified to 13 equal to 2x plus 8. Then bring the 2x to this side. It's going to be 4x plus 13 is equal to 8. Take away the 13 to the other side. That is 4x is equal to -5. Divided by 4, divided by 4, x is equal to -5/4. That's it.
Marvelous. All right, the last 4 problems of this series. Okay, we want to solve the following linear equations just like you've been doing. So notice the goal was to get the x's to one side and the constants to the other. So I'm going to do the same thing. I'm going to subtract 4x from both sides. That's going to give me 3x equals -2. Notice I have a multiplier here to the x, so I'm going to divide it away, and I get x is equal to -2/3. Over here, I've got constants and x's on both sides. So move your x's to one side, move your constants to the other. So I'm going to add 2x to both sides, and I'm going to subtract 19 from both sides. This is going to give me 5x. This cancels. This is going to give me, what do I get?
6.
Yeah, 6, and then what, 36?
6 and 4, 36, yes.
36, yes, and that cancels, and then I'm going to divide away my multiplier, so x is equal to 36/5. All right, over here, look at my mistake. Do you see my mistake? I subtracted instead of adding. This is 9, and therefore when I divide by 9, I get 4. Yay! Okay. All right, everybody makes mistakes. Okay, here we go. I'm going to combine like terms and distribute on this one. So over here I have 2x and another x. So I have 3x plus 7. Over here I've got 8x or 4x. I don't know why I'm doing this. Must be summer already. And plus 8 minus 5. I'm going to continue combining. So this is 4x, plus 3. Now I'm going to do the same thing, move my x's and move my constants. So moving the 4x to this side and the 7 to this side, I'm going to get negative x. This cancels is equal to, this cancels, negative 4. Don't want to leave x negative, so I'm going to divide both sides by a negative 1. This is going to give me x equal to 4. Over here, I'm going to be distributing on both sides and combining. So 4 times 1 is 4. 4 times negative x is negative 4x. And I have 3x. And I have this, negative 2x. And don't forget to do this one too, minus 2. Combining like terms over here, I get 4 minus x equals negative 2x minus 2. Moving my x's to the left and my constants to the right, as you can see, is my preference. 2x, I'm adding, and 4, I'm subtracting. This cancels, I get x is equal to, this cancels, negative 6. And that concludes our video for today. Bye.